Everyone. This is Professor Naji, the instructor of Math 111, the online class. And what I'd like to show you is how to use a very nice graphing calculator online called Desmos. And it is located at desmos.com. So go to any browser of yours and type just like that, desmos.com, as you can see there, and you hit return. And then after that, click on Start Graphing. And once you get that, first of all, if you wanted to graph anything, of course, you could just, type y equals, for example, 2x plus 3. And sure enough, notice how the line is already there and everything is great. But what I'm trying to show you is not this actually. What I'm trying to show you is how to plot your data um, for Lab 1. Of course, I have showed you in my documents in Moodle how to do that using a calculator. And of course, there are files also in the help files that show you how you use other, programs. But today I would like to show you how to use, Desmos. So you click on this little icon here. You see where it says table. So you click on that. Notice how there's x1, x2. At this point, I'm going to enter a silly data. In your case, you're going to enter your actual data of measuring the length around any round object and the distance across a given object. But in my case, I'm just going to enter some silly data of some sort. So 1, 2, 3, 4, 5, 6, 7. Okay. Now for here, I am going to enter the first, prime numbers. So I'll give you a second to think about the first one. Call 1, call 2, call 3. If you said 1, you're not accurate because 1 is not a prime number. The first prime number is 2. Next one, I'm assuming you guessed 3. The next one, 5, 7, 11, 13, and 17. Those are the first few prime numbers. As you can see here, already the program is automatically plotting these. Of course, you have a way of controlling this. You could zoom out, so you would be able to see more of the plots. You could zoom in, so you would be seeing more details. You could actually move everything if you want to, so like that, like this, and then you could zoom out a little bit so you would be able to see, all the points. And then you could move your graph. You don't have to move the graph thingy, but I'm just showing you. You can also control actually what you would like to be able to see in the graph. So for example, I can set my x stuff. For example, right here, I see that the x does not exceed 7. So it doesn't make sense to go from, all the way to 37. So for example, I could go from, let's say, -2, -2 to, let's say, 10, for instance. Okay, I can choose to do that. You see, look at that. And you can also tell it what kind of steps you could choose. You see what I mean? For example, you want to go a tick mark each, or 2 tick marks each, or whatever the case may be. For the y, we're going to do the same thing. We're going to go -2. But of course, since for the y, we're going up to 17, so we're going to go to 20. How about that? Okay. And no, not 220. Silly me. Okay. Got it, guys? Can you see that? Oh, by the way, if this bothers you, you could just, click on it and it'll disappear. And then notice here how, for example, like in this case, it's going in steps of 2. When you don't specify, Desmos will decide for you automatically. Good so far? I hope you said yes for that. Okay, so at this point, I am going to click somewhere, so we would close that. Of course, when you transfer this graph to your lab, it is important that you would label this axis, you label this axis, and go to the sample of the student so you would be able to see how that works. Now, how do you get the equation that would fit this? Well, technically, if you look at this here, it looks like it does not follow quite a straight line. Instead, it has like a little bit of a curve aspect to it. So technically, the equation, the best model that you should fit this for is probably maybe, I don't know, x squared or x cubed or whatever you want. But in our case, since we're going to be doing just a linear example, so I'm going to stick with a linear, but for this data, really, it's not quite the best model to use. But just so I'm trying to get you to see how this works, how do you come up with the equation? Well, interestingly enough, Desmos does this for you. You don't have to do it. Um, so in this case, I'm trying to see, oh, yep, okay. So you type the y1, which is the variable that you have, but instead of writing equal, no, you do a tilde, which is shift, and it's go to the key next to the left of the 1, you get this. This is called tilde, okay? And then you know that an equation is supposed to be y equals mx plus b, where m is the slope and the b is the intercept. So you type m and then times, which is shift 8, and then x1, so you would tell it, I am trying to get an equation involving this. If you don't type plus b, it assumes that your b is 0 right there. But in our case, we should never assume that for data that we collect. So we're going to say plus b. Interestingly enough, look at the beauty here, guys. Look at how it tells you automatically what the slope is, what the intercept is in this case. And not only that, it tells you the coefficient of friction, and in this case, it's equal to 0.985. And the square of the coefficient of friction actually is the percentage of linearity. So in this case, that means the x1 and the y1 have a linear relationship that is correlated to about 97.1%. If you click on the residuals, it would be cool if you would look it up and you try to figure out, and maybe that could be something you write in your discussions of the lab. Of course, if you use any outside sources, you must cite, otherwise you would be no cool. Anyway, so you could see here that it did this, and then it plotted, something right there. Of course, you don't have to have the plot for that. I mean, I'm just saying if you wanted to see that. So now generally, if the plot of the residuals is random, that means it's quite linear. In this case, it seems to have a little bit of a pattern to it, so it's not quite random, and that's exactly what I meant by saying that it's not quite linear. If it were quite linear, this should be 0.99, the R should be 0.99 something, and then this one should be 0.99 something, something like that. Okay? I just thought I would kind of include that. And of course, now I can hide it. I clicked on it. See, I click on it, showed, click on it, hide it. I hope this kind of helps you see how you. Of course, at this point, you could take a screenshot of all of this, and then you paste this onto your lab report, and that's it. I hope this kind of helps a little bit. If it does not, please let me know. Thank you very much. You are cool, and so am I. Have a good day, guys. Bye-bye.